All right, so this is page 10 in your packet. So we're to box and whisker plots now. So box and whisker plots, these are what you did in the 8th grade. They are math models that use that 5-number summary that we've been talking about and to visualize the spread of the data, like what the data is going to look like. So let's actually write that. All right, so a box and whisker plot is a math model that uses the 5-number summary to visualize the spread of data. It's easier to use this and interpret what you find whenever you use that 5-number spread. Let's put down here what those 5 things were. We had the minimum. We had the maximum. We had Q1. We had Q3. And we had the median, the middle data point. Oh, and you can't see that. Sorry about that. There we go. That was the 5-number spread. Okay, so I've got some data right here, and what I want to do is I want to find that data real quick. Okay, so here's my data, 12, 13, 13, 14, 15, 16, 18, 19, 31, 31, 33. So let's count how many there are. I'm going to ask you, I'm going to say pause your video here and do this, and then come back and let's see if you got it right. So I pause your video, see if you can do it, and then come back. All right, I'm going to count the data. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, that means number 6. 1, 2, 3, 4, 5, 6. That is the middle term. 5 on the left, 1, 2, 3, 4, 5 on the right. So the median is 16. The minimum value is 12. The maximum is 33. Q1 is the median of the lower, so 1, 2, 3. So it's going to be 13 for Q1. And the middle value, 1, 2, 3, is 31. Now, one of the other things that I usually ask whenever I'm working with data is I usually want to know what the IQR is. Now, I didn't on this one, but let's go ahead and do it. Just, we know we can, so let's do it. The IQR would be Q3 minus Q1. IQR represents the interquartile range, so that would be 31 minus 13. Yeah, Miss Dean's going to grab that just to make sure I don't mess it up. I don't want to make a video and then have my IQR be wrong. All right, so the interquartile range is 18. Now, what can you do with that? So you've got this data and you're like, you know, what could you do with it? Well, you would create a box and whisker plot. Okay, so what I'm going to do is I'm going to change pens. I'm going to start over here, right here at the minimum value. And if you remember, I'm going to put that there. So we say our minimum was 12. So the minimum was at 12. And then if you just start labeling this, just start counting all the way up. We're going to count by 1. So 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34. Okay, I'm going to label all these points. Look at this. Here's the lower boundary. Here's the maximum value. Now, I'm going to go ahead and draw this down. We had 33 was the maximum. Q3 was at 31. So here's that Q3 right here at 31. I'm going to put an arrow there. The median was over here at 16, and Q3 was at 13. This is what a box and whisker would look like. Now, you may remember that I'm just going to draw one up here, just an example, that they looked something like this. Okay, that's what they typically look like. And remember, this is the median, so this represents the 50% percentile. This right here represents 25%. Inside this box is 25% of your data. inside this box is 25% of your data, and on the outside here is 25% of your data. What this box here tells me, look how most of my data, look at this huge range of 18. Only 25% of the data should be down here. 25% of my data should be here. 25% of my data is here. Look how spread out it is. And 25% of my data is here. That's what the box and whisker tells us. Now, when you look at this, sometimes it can be a little confusing, like how this looks. So let me go and explain it with something that you know. You have all heard of a bell curve. And you even asked me when we first started this class, are we going to have that IB curve? And what the IB curve basically is like a bell curve. So I'm going to use this line down here. A bell curve normally starts, and then it curves up, and then it curves back down. And you would typically expect for most people, if this were a test, to fall right here in the median, right? Oh, that is really slanted, y'all. Sorry. And this is what you would expect. I was trying to, I didn't grab my green pen. That's okay. We'll go with black. You would expect this to be the 50% mark. Okay? And then here's what happens. You have this area here. This 25, and I'm using kind of my box and whisper. This is 25%, and this is 25%. But you have the minimum down here, and you have the maximum over here. Here's what you know. You know from the median this way is 50% of your data. And in a normal bell curve, this would be beautifully done. Halfway through, your grades would be going up, and they would come back down, right? And so this would be half of your data. And then this would be the other half of your data. And this would be a beautiful distribution of the grades. This has a name. It is called the normal distribution. It has a beautiful name. Now, I'm going to tell you we're not doing that just yet. Here's my highlighter. I'm just going to say this is called the normal distribution. It is also known as a bell curve, and that just means the data is beautifully distributed. Usually in a box and whisker, we can see the distribution. Is it normally distributed? No, not always. Because what will happen is maybe it shifts this way or it shifts that way. Or, you don't have to put this on your notes, but maybe your bell curve is the data is not spread out very much, and so the data is super close together. And so it might look like that. And so you get different looking bell curves. Most of the time you want this nice curve, but sometimes they're like super. Or maybe even it's even worse, and maybe it's just barely a curve at all. So there's different ways it will look. Again, we will get into that later. It's called the normal distribution, and it can be pretty fun. All right, let's take this example that we just did, and I want to go to the calculator, and I want to show you, and you can go to the next page if you want. In fact, I'll go ahead and go to that next page. And these are some calculator tips. Now, I tried to put some good examples on here so that you could follow it. So here's what we're going to do. I'm going to do the box and whisker plot, which you can see it down here. I'm going to do it on my calculator. Oh, y'all, the calculator is about to blow your mind. Okay, so here we go. We're going to go ahead and clear our calculator out. Hit second plus 712, and we're just going to clear the RAM. We're not going to clear the whole thing, just the RAM. Right, let me move that out. So when you want to do the box and whisker, we're going to go to edit. Actually, I'm sorry. We're going to go to stat. Let's go to stat first. And then we're going to go to, and let's do it here. We're going to go to edit. Now, this is just some different data. So we're going to put their data in that they have here. So they're just doing an example. Let me make this so we can see a little. Oh, sorry, y'all. I was trying to make it a little less bright. There we go. Okay. So stat, edit, and let's put this in 4, 5, 6, 7, and then go to the other side. We're going to do 7, 13, 10, and 10. This is what this says. You have some data that you collected, 4, 5, 6, and 7, and this is the frequency that it happened. That's the frequency that whatever this number is that we're collecting happened. So we are going to stat calculate. Now we're going to do a one variable calculation. Here's what it wants to know. What list are you using? I'm using list 1. What's the frequency? The frequency is list 2. So you're like, how do you get an L2 there? You're going to hit the blue second button right here. And then you're going to go down here, see number 1 how it says L1 and number 2 says L2. So you're going to hit the blue and then L2. And it's going to put it there. Now, the downside is it's going to stay L2 unless you change it. And there are sometimes you want to have different frequencies in there. So just always watch that. Okay, so now we're just going to hit enter and we're going to calculate this. Here's what we find out. Look at all this data. This is the median, or this is the mean. We're going to go down here and look at these number values right here. Look, the minimum is 4, the maximum is 7. Oh, I forget, it won't let me touch it. Q1 is 5, the median is 5.5, and this is 6.5. Is that not amazing? Now, I want to see the box and whisker. What does the box and whisker look like? So here's what we're going to do. We're going to hit second stat plot. I had to think about how I got there again. I don't think I told y'all on that. I'm just sorry. Second stat plot. Okay, and we're going to go enter. Now look at these right here. See that? That's the box and whisker right there. So you're going to go down and over to the box and whisker. Not the first one, but the second one. Box and whisker. It's saying, where do you want to use it? I want to use L1 and L2. That's where I want to get this from. You can change it to any color you want if you like red or black or magenta or green or orange. I wanted to go with red. Oh my goodness, I didn't know there were that many colors. There we go, red. And then I'm going to hit graph. And I can't see it, so I'm going to hit stat. Not stat. Go back to graph. I'm going to hit zoom. And I believe it's statistics. I think it's 9 is what I want to hit. No. All right, hold on. I got to remember. See, this is good. This is why we make the videos. Zoom. Let me go zoom out. I know it's up here. I didn't think it was over that far, though. Oh, I don't think I turned it on. Hold on. Second stat plot. Just fast forward through this. Enter. Enter. Frequency is L2. And then graph. Oh, okay. What did I do wrong? Let's read. On. Is my stat plot on? Oh. Yeah. Oh, I didn't turn it on, y'all. You gotta turn it on. Stat plot on. And then I go to 1 and 2. I did that. Don't you like how we troubleshoot while we're... Oh, there it is. I forgot to turn it on. Zoom 9. There it is. Oh my goodness. These are good things to do. I hope you fast forwarded through that and you didn't watch me sit there and struggle. Okay, so there's that. Going back, stat edit, stat calculate, one variable. I want to go back and show you all the data points that you've got there. There they are. Second, stat plot. Make sure you turn it on. I did not turn it on. Then go down here, pick what you want. I picked this one, L1 and L2. It was red. I graph it, and there it is. The zoom, I did zoom 9 for statistics, and it zooms in on whatever stat is we're doing there. Now, what I wanted to do is I wanted to go back on here, but I wanted to go to this data here, and I want to put that in so you can see it. So we're going to go to this, and here's what we need to do on this. We need to create a frequency table. I'm going to look real quick and see what my next one was. Yeah, we're going to create a frequency table. So let's go with 12, 13. I'm just going to make it here. I'm just going to call it L1 and L2. Make sure I've got that. 12 occurred once. 13 occurred twice. 14 occurred once. 15 occurred once. 16 occurred once. 18 occurred once. 19 was 1. 31 was 2. And 33 was 1. This is my frequency table. So what we're going to do, if you've already got it, you can skip this, but I'm going to put it in there. Stat, edit. I'm going to go up, clear, down. 12, 13, 14, 15, 16, 17, 18, oh, no 17, 18, 19, 31, 33. Over here, 1, 2, 1, 1, 1, 1, 1, 2, and 1. Okay, so I've got all my data in. I'm going to go to second stat plot, turn it on. It's on. I'm going to graph it. Now, I need to zoom again. There it is. Now, what you should notice is that these look very much the same. Look how the data is super spread out, just like it is here. I could do the stat calculate one variable, and let's check it. Where's all my information? This is what I got here, right? Look at that. The minimum is 12. Q1 is 13. The median is 16. Q3 is 31. And the maximum is 33. My calculator just did all that for me. Now, you know how to calculate it by hand as well, which is important to know. But, I mean, goodness, we already know how to do that now. Now we can just use our calculator. Okay, here we go. So, moving on. Now that you know how to do that. What's funny is, y'all, I even wrote myself a note, Zoom number 9 stat, and I was sitting there trying to figure out how to do that. And anyway, you know what? Let's do this while I'm thinking about it. Let's put this on here. Let's do Zoom number 9. Oh, just to remind you, that's how you want to zoom to get to see it. To let's say Zoom number 9 to see graph. And you might even just put some notes on there so that we don't forget that. Okay, here we go. Distribution and skewing of the mean. Now we're not doing the median, now we're doing the mean. All right, another aspect of the spread that a box and whisker plot can indicate is whether the data is approximately normally distributed, positively skewed, or negatively skewed. Now, I'm going to do 3 scenarios showing you how this can happen. A normally distributed data, that normal bell curve, it should look like this. It should start here and travel. And then we should have our box and whisker. It should look something like this. And then it should continue on. And what you notice is this is about the same as this. The median is in the middle. And this would be a beautifully normally distributed graph. Now, let's do a positively skewed graph. All right, it would start here, and it would go, and then it would have its table here, its little box, and maybe the median is still right in the middle, but positively skewed means this side over here, super long. It's positive over here. So this is positively skewed on the positive side. I'm going to highlight that. That's positively skewed. So you can probably already guess what a negative skewed one's going to look like. I'm going to do that in blue. The blue and purple is hard to tell apart, but negatively skewed, it's going to be the opposite. That would be here. All right, so this would be negatively skewed. And again, it kind of makes sense. That's why a lot of people like statistics, because like it kind of makes sense. I can figure it out. Okay. One other thing that we want to put in this is while you're talking about skewed, we also want to talk about something called outliers. This is a big part of statistics. If you become a statistician, you are always looking for those outliers. All right, so remember, outliers are when the data, maybe there's an error when we collect it or something happens. And so you have a box and whisker. It looks like this. And the question arises, is this point out here, is it an outlier? Or maybe this point over here, is it an outlier? Is it too far from the data to decide whether or not we can use it? Is it good data, or does it have an error, or maybe it has bias? On the negative side, when you're on the left, to determine if it's an outlier, you take Q1. So you're going to take whatever this number is right here, Q1. I'm going to put right here, Q1. And you, because you're going negative, you subtract, excuse me, 1.5. So 1.5 times the IQR. Whatever that IQ, that interquartile range is, that's how we're going to use it. Now, if I'm on the other side, if I'm positive on this side over here, is that point an outlier? Well, that's going to involve Q3. And we're going to say, okay, well, we need to take Q3. And over here, we had to subtract off this distance. Over here, I hope it makes sense that we would need to add on 1.5 times the IQR. That tells us if it's an outlier or not. That's all you have to do. They give you a value. You find that you're going to have to find the interquartile range, and then you're going to use that to decide if it's an outlier. So let's actually look at something where we do that. All right. So here we go. A student records their hours of sleep for 60 nights. Now, pay attention to words like this. That means they only did this for 60 nights. The following box and whisker diagram is drawn from the data set. Estimate the number of nights that the student sleeps less than 5 hours. Take a second and look at it. Remember, it's divided up into quartiles. 25%, 25%, 25%, 25%. So that means this, even though it's long, this data right here represents 25%. This right here to the median represents 25%. This little piece here is 25%. And this big piece here is 25%. Oh, that is not very pretty. All right, so estimate the number of nights that the student sleeps less than 5 hours. Well, if I look at this, this is the hours he's sleeping. Here's the 5 right here at Q1. And so what I want to know is estimate the number of nights. Here's what I know. I know that we did this for 60 nights, and from here to here represents 25% of those 60 nights, right? Because all of this is 60. This little piece here is only 25%. This would be 25%. This would be 20%. So 5 is right here at Q1. So 25% of the nights, he slept less than 6 hours, or less than 5 hours. So I'm going to take 60 nights, multiply it by 25%, and figure out that's the number of nights he slept less than 5 hours. So 60 times 0.25 is 15. Yes, that easy. So that means 15 days represents how many nights he slept less than 6 hours, or less than 5. I keep saying 6 hours. So I'm going to say that 15 nights out of 60. He slept less than 5 hours. All right, students are playing a game where they earn a badge each time they master one of 20 different skills. So here's representing those 20 skills. The table shows the frequency, the data, and the number of badges of a sample of 60 students. Create a box and whisker. So they've given us this data. We have to create a box and whisker. Lots of different ways we can do this, right? We could put real quick, let's take this and let's do a I'm just going to put cumulative frequency. Let's do that real quick. Remember, cumulative frequency is where we're going to add all this up. So we're going to say this is 1. 1 plus 6 is 7. And then just keep going. 7 plus 9 is 16. 16 plus 10 is 26. 26 plus 13 will be 39. 39 and 7 will be 46. 46 and 8 will be 54. 54 and 5 will be 59. 59 and 1 will be 60. And look, it adds up to those 60 students. Okay? Here's what else I know. To do a box and whisker, I need to know a couple of things. I need to know the lower boundary, I need to know Q1. I need to know the median. I need to know Q3. And I need to know the upper boundary or the maximum. I do know that I just learned how to do that on my calculator. So I'm going to do it by hand and by my calculator because you never know which way. Maybe I take the calculator away and make you do this on your own. All right. I wouldn't, but just in case. I want you to know how to do the math. All right. So here's what we know. We've got 60 students. So the median of the 60, right? Here we go. Let's do 60 people. We're going to divide that in half. That would be 30. So the 30th is the median. I need to figure out where does the 30th data badge, whichever way you want to look at it, occur. Well, here's 1, here's 7, here's 16, here's 26. Okay, so this right here in 16, inside the 16, the 30th badge occurs. So that means the median is 16. All right. Now, this was 30 to find the median. We need to take 30, divide it in half. So 30 divided in half is 15. Where does the 15th badge occur? Here's 1, here's 7, here's 16. That means that within the excuse me, the number of badge at 14 is where the 15th one occurs. So that means Q1 is 14. Q3 is going to be 30, the median, plus, I'm going to go up 15, so it's going to be at the 45th. The 45th tile is where the Q3 is going to go. So where's the 45th? Well, if the 46th is right here, then actually the 45th occurs right in here too at 17, right? 46 is here, so is 45. All right, so we could say that that one, I'm going to circle that one, is where that one occurs. The lower boundary, what's the lower boundary? Lower boundary would be 12. The upper boundary would be 20. And now I can do my box and whisker. All right. Lower boundary is 12. I'm going to say 13 right here. 14. Actually, let me just draw that. 15. 16. 17. 18. 19. 20. All right. We're starting at 12. We're going to go to 14. That's where Q1 is. And Q3 is going to go to 17. The median's at 16. And the upper boundary is at 20. So I would want to label this Q1, Q3, and median. And there it is. Did they ask for anything else? Let's go ahead and do the IQR. I don't know if we asked for that, but we'll put it on there. That would be 17 minus 14, which would be 3. The interquartile range would be 3. Now, could I do this one on my calculator? You bet. And some of you may have already done it. Here we go. Stat. Let me clear all this out. 12, 13, 14, 15, 16, 17, 18, 19, 20. 1, 6, 9, 10, 13, 7, 8, 5, and 1. Stat, calculate one variable. Frequency is L2. Here we go. Does it match? 12, 14, 16, 17, and 20. Was that faster? Absolutely. But I wanted you to understand the math back here behind it. All right. Let's do our check for understanding on this. All right, so cumulative frequency curves. And I feel like you kind of need this a little bit. Oops. Sorry, I'm going to get that on there. It'll help us understand it. Okay, let us consider the data collected from a survey of the members of a badminton club. Each of the 70 members was asked to record their age. The data was compiled into the ranges and used to create a frequency table in which X represents the member's age. So here we go. So let's take a second. Let's make the cumulative frequency. Pause your video, see if you can do it. I'm going to do it as well. So I'm going to start with 3. 3 plus 10 is 13. 13 plus 18 is going to be 31. 31 and 24 is going to be 55. 55 and 12 is going to be 67. 67 and 3 give me 70. And I know that each of the 70 members, there's my 70 people right there. Now I want to create a histogram. Okay. So on the histogram, I'm noticing that my bins are 20 to 30, 30 to 40, 40 to 50. So I do notice that these bump up right on each other, right? So here's what I'm going to do. Remember I showed you guys how you can do the little jagged line. So I'm going to do that to right there. And I'm going to start right here and I'm going to make this 20. And then I think what I'm going to do is do 2, 4, I think I'm going to do 2, 4, 6, 8, 30. 2, 4, 6, 8, 40. 2, 4, 6, 8, 50. 2, 4, 6, 8, 60. Oh, hold on, I lost it. 2, 4, 6, 8, 60. 2, 4, 6, 8, 70. 2, 4, 6, 8, 80. All right, and up the side, I think I'll just go by 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So as I do this, I am looking at the frequency. Oh, sorry. I'm looking at the frequency table, and so I need to be able to go up to 24. So I'm going to mark the numbers that I need. I should have marked 12. So I'm going to need 12. I'm going to need 18, 12, 13, 14, 15, 16, 17, 18. And I'm also going to need 24. 19, 20, 21, 22, 23, 24. So I was being a little bit lazy there. I just wanted to mark the ones that I knew I was going to need. To make the histogram, my first bin is 20 to 30, and I've got 3. So I'm going to go up to 3 and over to 30. My next bin is 30 to 40, and I'm going up to 10. All right, color that in. The next bin is 50, and it's going up to 18. These are hard to do. All right, 24. And 12 on the next one, so right here. Notice my intervals are all the same width, and then 3 is 70 to 80. All right, so there's my beautiful histogram. All right, let's label all this. The lower boundary, the upper boundary. Let's do Q1. Let's do the median. And let's do Q3. Oh, and let's do the IQR. All right, so I would encourage you to pause your video here and see if you can go do that, and then come back and turn your video back on. All right, I'm assuming you already did that. So here we go. So the lower boundary would be 20. We can see that. And we can see pretty much that the upper boundary would be 80. All right, so where are we going to go to get that Q1 and that Q3? So it might be, you know what, I'm sitting here looking at this and I'm like, okay, let's do this first. Because I did it backwards. We should have done this before we did this. Because looking at this, that would be a little bit of a challenge. What I would tell you to do is, let's make your cumulative frequency graph first. So let's come back down here and we're going to take this and we're going to put it down here. It's going to be, oh my gosh, it's so amazing. Okay, so what I had to do when I was making this is I had to graph it myself because it was too difficult trying to do it on our own. So if you look at this, this is a cumulative frequency graph. It starts at 20 and it goes to 80, just like our graph did. And what I did was I went ahead and drew the lines out for you so you could see them a little better. Because this is the type of thing that IB would give you. In fact, I will give it to you on a test. What I want you to do is to look at this. This is representing the data above. And what it's saying is, here's the cumulative frequency of this data. What is the median? Well, you know that we had 70 people, right? So what we need to calculate is what is our half of where we started. So 70, what's half of 70? So in fact, let's do it this way. Let's do half of 70 would be 35. So on this 70, I'm going to find the middle of it, which was 35. It's right here. So you go across until you hit the cumulative frequency, and then you go straight down, and you see that point right there. That point is about, and I know it's a little bit hard to see on here, but that point comes out to be about 52.5. Okay, or I'm sorry, that's the median. I'm going to point to it. That is 35 right here, 35. And when you follow it down, it comes here to about 52 if I was guessing. It's about 52. Then you want to do this upper half. You want the midpoint. And remember, you're not really looking at the curve. Halfway between 35 and 70, that's that 52.5. So you go to 52.5 right here, 52.5, which is that point right there, 52.5. Again, that's halfway between 75 and 70. Halfway between 75 and 70 is 52.5. You go straight over, because remember, these are quartiles. Everything's quartiles. And you go straight down, and you look and see where you land. Looks to me like you land at about 59. So this is going to represent your Q3. This one's going to represent your Q1, and this is going to represent your median. Remember, it's all about making those box and whiskers. So to find Q1, you go from 0 to 35. Halfway between would be 17.5. So you go to 17.5. You go across until you hit the curve, and then you come straight down. And when you look, that data point, like it should be about 43. I know it's super hard to tell on our packets, but it would be about 43. And so looking at it by hand, that's about what I would guess it. So if I were to make a box and whisker, my lower value would be at 20. And I tend to just make a long line to start with. My upper value is at 80. And I'm going to do 30, 40. I may have messed up on this. 50. Yep. 60. Oh, I'm going to move that over just a little bit. Hopefully you got some white out. It's always good to have 70 and 80. I just want to kind of have it on there so that I have it all. Let's see. We did 43. So we're going to say right here, we'll come and say about 43 all the way up to 59. So we'll say about right here. And then 52 was our median. So I would say this is Q1, this is Q3, and the data goes all the way to 80. and it goes all the way down here. So if I wanted to do my points on here, I would go back up here, and that was why I was like, oh, we couldn't do that while ago. I would say that my Q1 was at 43, my median was at 52, and my Q3 was at 59. My IQR would be 59 minus 43, which would be 16. There we go. And there it is. Now, could I do it on the calculator and maybe get some better answers? Yes. We could do the same thing and we could get way better data on our calculator. So let's try that. So let's go stat, calculate, stat edit, sorry. Let's clean that up. Now, here's the deal. This is an interval. Remember, we can't put intervals into our calculator. So what do we do in order to put this into our calculator? We have to find the mid-interval point. So I'm just going to come out here to the side. Halfway between 20 and 30 would be 25. Halfway between 35 and 40 would be 35, 45, 55, 65, and 75. So this is going to be L1. The frequency is going to be L2. I'm not going to use the cumulative. I'm just going to use that other one. All right, so here we go. I'm going to do 25, 35, 45, 55, 65, 75. And you go over frequency it occurs. Now, is our data going to match? No, because we were using the actual graph when we did this one. This one's going to be a little different. So let's write the word calculator down here. And let's see what our calculator says. Things we're looking at. What's the lower bound? What's the upper bound? What's Q1? What's Q3? And we could do the median too. So I'm going to do stat, calculate a one variable statistics. L1, L2 is my frequency. All right, here we go. The minimum is 25. The upper is 75. Q1 is 45 and Q3 is 55. And the median is 55. Oh, that's an interesting one. The median is the same as Q3. Now, if I wanted to graph it, I could do second stat plot. Hit enter. Everything's turned on. I'm going to hit zoom 9 so that I can see it correctly. And there it is. And I believe you can go up here. Let's see, is it calculate? No, it's not. I can't remember what it is. We'll get to it whenever we get. I'll show you guys when we get to where you can look at the different points on there. Maybe it's trace. Oh, yeah, there it is. You can go to the different spots. So it says Q1's 45. The median is 55, Q3 is 55, and then the maximum is 75. It was trace. I hit trace, and that's how I did that. So you can use your calculator, but because it was mid-intervals and not the actual 20 to 30 that we were doing, this right here encompasses that whole entire interval and everything. So, all right, cognitive homework. Yeah, it's not number 1. This would be homework. You know what? I'm not sure. So I'm going to leave that blank, but in class I will tell you what it was. And I believe that, make sure I'm done. Yeah, because I believe we're going to be ready for our quiz now. Hope that helped.